And I want you to answer these problems that I'm going to show. Make sure that this particular exercise is basically to check whether you are still remembering the basic antiderivative and derivative rules that we've had before. If you can get all of them correctly, that means you're doing your work on practicing your rules in answering calculus problems. So let's see if you guys are doing your homework. Can you please give me the derivative of this function? And you can unmute yourself because right now I'm on a different mode, so I cannot see the chat box. So can you please just unmute yourself and tell me what your answer is?
0.
And that is correct. And again, in mathematics, you should know your constants, and constants would come in any or many forms and sizes, just like this. 2 is an obvious constant, but for most students, pi or e, they would think that they are variables. Make sure you know your constants. How about this one? Can you please derivative? What is the derivative of secant 5x? Can you please say your answer?
Is it secant?
And 5x times 5.
5 secant 5x tan 5x?
Yes.
Maybe. And yes. So the derivative of secant u is secant u tan u du dx. So make sure you know that. Next. What is the antiderivative of secant 5x times cosine x dx from 4 to 4? People are like, we haven't done that yet. Is there anyone here who has an answer? Take a guess. Shoot it. I guess no one. The answer is 0. So notice that the integral sign, we have the lower limit and the upper limit. If your lower limit and your upper limit in any integral function, when they are the same, the answer to that antiderivative is going to be 0. So this is one form of definite integral. What we were working on last week, we call it indefinite integral because there's no lower limit and upper limit. And we're going to be working on that probably next week, how to find or work on problems involving definite integrals. So remember, one of the properties of a definite integration is that when the lower limit and the upper limit are the same, the answer is 0. Give me this. What is the integral of x to the negative 1 dx? Unmute yourself if you know the answer.
Undefined.
Michael says undefined. Is there anyone here who have a different answer?
I was saying ln, I think, but
ln what?
ln,
Just
ln
ln?
x. No, it's the bars. Shoot,
ln the absolute value of x.
All right.
Here you go. I concur.
ln x plus c, or ln absolute value of x plus c. And this is a common error that most students do. Remember, last week, I gave you this particular problem and we solved it using the power rule, and it turned out to be x to the 0 all over 0. So in calculus, make sure that you will remember this particular properties in your rule. X to the negative 1 is ln of x plus c. Next. Give me the ddx, the derivative, not the integral, but the derivative of 5e squared.
0.
0.
Good job. Now you know your constants. So make sure that you are aware of your constants, because if you know your symbols in mathematics, you'll gain more confidence in answering problems like this. How about this? Derivative. If you have an answer, just say it.
I'd say negative 3x sine x.
Negative 3 cosine x squared sine x.
Oh, so with the square or without the square? So in this particular case, cosine cubed x or cosine to the 3x can be modified into cosine x raised to 3. Remember that in trigonometry, there are two ways on how to write down exponents. Sometimes it's in between the trig function and the function. Sometimes it's inside the parentheses. So one version of this is cosine x raised to 3. So if that's the case, we'll see it clearly that we can use the chain rule. And the chain rule is bring down the 3, copy the inside, raised to 2 times the derivative of the inside. And the derivative of cosine x is it negative sine x?
Yes.
So that's why it's negative 3 cosine squared x sine x, I think. Ooh, there. So remember, in calculus or in any math problems, notations are extremely important. So if you know how to write things in several ways in mathematics, it will be a lot easier for you to solve problems similar to this one. So know your notations. What about this? Simplify. I'm not asking for the derivative. I'm not asking for the antiderivative. But what is the
Cosecant x.
other best version of 1 over sine x?
Cosecant.
Yes. So make sure that you also know this, because sometimes there will be questions like, what is the ddx of 1 over sine x? Or what is the antiderivative of this particular trig function, that when you don't simplify it, it's a little bit complicated or a little bit difficult to work with. But when you modify it, just like what we did a while ago, it becomes a lot easier. So know your formula so you can modify functions like this. How about this one? What is the simplest form of sine x all over cosine x?
Tangent x.
Yes. So that means if you see problems like ddx of sine x over cosine x, you know that by modifying it, you'll be able to solve for the derivative of tangent x, which is secant squared x. But right now it's just simplifying, so it should be easy. How about this one? What is the value? What is the actual value of tangent 45 degrees?
1.
1. Tangent 45 degrees is equal to 1. And that is correct. So you also need to know, at this point in the game, the basic values of your sine, cosine, and tangent function. So make sure you know your unit circle really well. And this one is another value of the unit circle. Tangent 45 is 1. How about this? What is the antiderivative or the integral of 5 pi squared dx?
5 pi squared x.
Plus c.
My bad. I was close.
And that is correct. So it is also a constant. So you know that this is just 5 pi squared x plus the constant c. And again, the reason why we always have the constant c is because if we took the derivative of this function, we know that the derivative of the function would be, someone is calling me, would have a constant, and any constant, the derivative of that is going to be 0. Okay. And we're done. We're done for the day. See you guys next week. Bye.
Really already?
Bye.
No, we're not done. How am I going to go back? All right. So today we're going to be working on U-substitution. And you still remember your basic antiderivative rules. So today we're going to do or add another skill in our arsenal, and that is finding the derivative of some function that you think is impossible to work with. Let me find the antiderivative of 2x square root of 1 plus x squared dx. Okay, this one is a lot easier. What's your answer? Ow. No one answered? Okay.
Well,
Okay, let's answer this together. This is your second example. What is going to be my u in this function?
1 plus x squared.
All right. And what is the derivative of my u?
2x. dx.
Yes, don't forget that because that is important. So 2x dx, and then we're going to modify this, and we are going to change this into 1 plus x squared. So we'll have 2x square root of u, right? Times dx, right?
Yes.
Okay. Now, what do you notice? Or you're not noticing anything? This is what I'm noticing. Boom, boom. What does it look like?
The du.
Yes. So that means you can replace that annoying 2x dx with just du. So now we have u to the 1/2 du. Are you convinced?
Yes.
So now we're going to use the basic rule of antiderivative, right?
Wow.
1/2 plus 2 over 2 plus 2 over 2 plus c, right? So now we have, what's 1/2 plus 2 over 2? 3 over 2?
Yeah.
2/3 u to the 3 over 2 plus c. But we need to be consistent with our function. So this is going to be 2 over 3 square root of 1 plus x squared raised to 3, right? Did I do my conversion correctly?
Yes.
All
I
right.
got that same answer. Cool.
Why didn't you say that?
I was waiting for you to do this to show everybody else.
Yeah, right. Okay, now
Bet.
let's do another one. Hopefully, like Michael, you'll be able to answer this correctly. Is that
All
Michael?
right, I will. Yeah, it is. I'll answer the next one out loud.
All right. But wait for them to complete it. If I say go, then you say it. Okay, ready? Antiderivative of x to the 3rd quantity 2 plus x to the 4th raised to the 5th power. Don't forget the dx. Again, in calculus notations, they are extremely important because that's part of the work. Okay. Show me the work. Yeah, I made a mistake. I chose the hard problem at the very beginning. That's why most of you were thinking this is a problem that's difficult to answer. No, that one is very advanced.
I'll keep the parentheses and square root that to the 5 as my u, right?
Yes.
I'm just asking. Okay.
Yes. Because your entire u is going to be the parentheses, right? That's why this is similar. This is a version of the chain rule in antiderivative. We don't call it chain rule. I mean, antiderivative of chain rule. We call this U-Substitution, but just for you to connect this with the previous lesson we did. So think about chain rule. there anyone here who's absent? Alyssa, Catherine, David, Eternity, Hayden, Joey, Kiana, Marvin, Michael, Raul. Everyone's present. Finally, 100% attendance. This time, you will have a constant because there is an annoying constant in your DU.
I was gonna say x raised to the power of 3 plus 1 over 3 plus 1.
Say that again.
X raised to the power of 3 plus 1, and then all over 3 plus 1 to start off on the antiderivative.
That's not what I got.
Yeah, I got something different.
I'm looking at a constant of 1 over 24.
Yeah, that's what I got.
Okay.
You have that in your answer? 1 over 24?
Yeah.
Okay. If you have 1 over 24 anywhere in your answer, then probably you're doing it correctly. Now, let's answer this. Of course, we need the U, and the U is the inside. 2 plus x to the 4th. And the du is 4x cubed dx, right?
Correct.
Okay. Modify. I will just modify the u, not everything else. I'll still copy x cubed. I'll still copy u to the 5th and dx, right? Now, what do you notice about this and this? Do we have something similar to our du? Yes or no?
Yeah.
Yes, because we have x cubed dx. But what are we going to do with the annoying 4?
Multiply by 1/4 to both sides.
1/4, 1/4. So now we have 1/4 du is equal to x cubed dx, right? So that means this x cubed dx will turn into 1/4 du. Not just du, but 1/4 du. So by modifying this again, we now have the integral of x cubed and du becomes 1/4 du. So let's just say u to the 5th times 1/4 times du, right? So what do we know about the constant rule? Get rid of it. I mean, ignore it for a while. Put it outside and focus on u to the 5th du. And what is the derivative of u to the 5th du? I mean, antiderivative?
U
U to the
6.
6 over 6
X
plus c.
plus 3, but we have a 1/4. So we have
U to the 6 over 24 plus 1/4 c.
plus 1/4 c. And can you simplify this? I mean, modify it. 2 plus x to the 4th, right?
Yes.
Yeah.
Plus. Now in integration or in integral, if we have a 1/4 c or any constant with a constant, since it's a constant with a constant, just write a constant. They're just the same.
Okay.
Okay, so that's why in most books or in my examples, I always write just the constant c because it's any constant. So just write c. But I don't want to confuse you with not using proper algebra because we're taking the antiderivative of this function and then the constant, so you need to distribute it afterwards. So just to make sure that you're doing or using algebra right. Next. Oh, let's try this. Ready for a little bit more challenging problem?
I guess.
Let's throw in
I'm ready to do some laundry.
Let's throw in some trig function. Integral of secant squared 1 over x. Is that the right function? Give me a sec. All over x squared dx. Ah! Okay. Show me that. It may seem impossible to solve, but remember, always start on something you already know, which is parentheses, right? Okay, do that. U-substitution is like solving a jigsaw puzzle.
This was in the video.
Oh, this isn't the video?
Yeah, it was.
Okay, so now you can answer this without looking at the video. So try it. Because I'm pretty sure, even if you copied it and watched it, some of you didn't really understand it. Now, let's see if you can now answer this on your own without looking at your notes. Were you able to answer this easy? I mean, without looking at your notes? Okay, I'll answer it with you. What's gonna be my u? There's so many functions here. What u am I going to use?
It's 1 over x.
Yes, 1 over x. And let's modify it to x to the negative.
Okay.
Because we don't want to use quotient rule. What is the derivative of x to the negative 1?
1 over x squared.
X to the negative 2, right?
Yeah.
And let's modify it again into negative 1 over x squared dx, right?
Yep.
Okay. Now I'm ready to modify my original function and put it into the integral of secant squared u over x squared dx. Now, what do you notice? Or are you not noticing anything? Okay, let me change it again. Integral of secant squared u times 1 over x squared dx. Are you seeing it now?
Yes.
Okay, so what am I gonna do now?
Change the 1 over x squared dx to du.
Oh, I forgot that. Right here. This is supposed to be du. Okay, my bad. All right, not just du, negative right here.
Negative, yeah.
Yes, so I'm going to multiply both sides by negative so that I can have an identical 1 over x squared dx in my function, right? So this one is going to change into the integral of secant squared u times negative du, right? And we know that the negative is similar to a negative 1, and a negative 1 is a constant. So let's set it aside. Can you now integrate secant squared u du? Yes or no?
Yeah.
What is the integral of secant squared u du? It's in our formula sheet.
Negative tan u plus c.
Yes. Negative tan u plus c, or negative tan 1 over x plus And that is its antiderivative. Did you get it?
Yes.
I hope so. Okay,
It's getting there.
you're getting it now?
Just a little bit.
Good. Let's test it. All of you should get this right because this is an easy problem. What problem is this? Number 4? Whatever, I lost track of time. Negative 15 x to the 4th negative 3x to the 5th minus 1 raised to the 5th dx. All right. Okay, can you please integrate this?
I'm just throwing some numbers out there, but I got negative 3x to the 5th minus 1, all raised to the 6th divided by 6 plus c.
And
That's
that is
what I got too.
I need to answer it anymore because that's the correct answer. Or another version of that would be 1 over 6 and then the parentheses. So both of them would be.
Okay.
And for those of you who are wondering how they got that answer, u is negative 3x to the 5th minus 1. The derivative of that is negative 15x to the 4th dx, right? Right?
Yeah.
So I'll have the integral of negative 15x to the 4th, u to the 5th dx. And I know that boom boom is boom boom. So I have u to the 5th. So this is an easy problem because it's pretty obvious they're there. So this is gonna be u to the 6 over 6 plus c, right?
Yes.
To be consistent, so it's 1 over 6 times negative 3x to the 5th minus 1 to the 6th plus c. I mean, you can write it as all over 6 or 1/6 outside. And again, in calculus, the more notations you are more comfortable on using, the better. Okay, let's have another one because practice is mastery. If you don't practice, if you're just sitting there, I don't know, watching Netflix and putting us on mute, shame on you. Let's answer this. The integral of 5x to the 4th plus 5, 2 over 3 times 20x cubed dx. All right. Do that.
3/5 times 5x4 plus 5 to the 5/3 plus c.
And that is correct. 3 over 5 times 5x to the 5 times, raised to 5 over 3 plus the constant c. Do I need to show it? Okay, I'll show it. Since this is easy. U is 5x to the 4th plus 5. The derivative of that is 4 times 5 is 20x cubed dx, which is exactly that. So we have u to the 2/3 du, and the antiderivative of that is u to the 5 over 3?
Yeah.
5 over 3, 3 over 5 plus c. And 3 over 5, 5x to the 4th plus 5, 5 over 3 plus c. All right. Now, notice that when I was starting to work out problems on U-Substitution, I always do it step by step, and I always show every single step, even though I know I can do a shortcut. So once you get comfortable with working on problems like this, you can use your shortcuts, but make sure that you are accurately working on those shortcuts really well. So it takes a while to be able to come up with your own technique. And to be able to do that, you need mastery. And speaking of mastery, let's have another one that it's a little bit more fun. the integral of 5 plus ln x to the 5th over x dx. All right. Take a shot.
I forgot what the derivative to ln x is.
All right, guys, help him. What's the derivative of ln x?
Is it 1 over x?
1 over u du. So ln x is 1 over x. dx, right?
Thanks.
And again, the more formula that you can remember, the better you will be in answering problems in calculus. And again, there's no shortcut. You just need to practice it to be able to remember it. So calculus will only become easy if you can memorize as many formulas as you can. And that's not an easy task. Unless you see calculus every day, then it's easy.
Okay, I got 1 over 6 times 5 plus ln x to the 6 plus c.
And that is correct. So problems like this can be a little bit intimidating because the function is weird and we're so used to just answering baby functions like polynomials or square root functions or parentheses functions. But when we are presented with problems like this, our first thought is that it's an impossible problem to solve. But if you know your derivative, this is constant, so it's 0. It's 1 over x dx. And that is our function that we can modify. So we have u to the 5th all over x dx. And we know that this is also u to the 5th times 1 over x times dx. That's another version of that function. And this is obviously the same as that. So taking the antiderivative is u to the 6 over 6. Okay, I'm doing shortcut this time. Let's not skip a step. Integral of u to the 5th du. So we have u to the 6 over 6 plus c. So 1/6 u is 5 plus ln x to the 6 plus. Is that your answer?
Yes.
Yeah.
Let's make it more fun by throwing in some trig functions. The integral of 20x sine 5x squared minus 3 dx. Okay. Do that. That's 5x to the square. What is your u function in this problem?
5x squared minus 3.
Yes. So that people can somewhere, that will be your u. Okay. Now you're on your own. You have an answer?
Yeah, but I don't think it's right.
Okay, tell me.
I got 2 cosine 5x squared minus 3 plus c.
All right, so Rebecca says 2 cosine 5x squared minus 3 plus c. Almost. I'm not calling Marvin. I'm just saying almost correct. What do you think is missing here? Okay, let's answer this. Why is it almost? What's the derivative of this? Hey, what's the derivative of u?
And x dx.
10x dx. All right, so 10x dx, and let's change this into the antiderivative of 20x sine u dx, right? 10x dx, dx, x, but there's 20 right here. So how am I going to fit it in?
Can you multiply both sides by 2?
Can I multiply both sides by 2? And yes, you are correct. Let's multiply both sides by 2. So this will be 2 and 2. So now we have 2 du equals 20x dx, right? And now we have an identical function, 20x dx. But this time, it's not just going to be du, it's going to be 2 du this time, right? So I'll have the integral of sine u times 2 du, right? Did I do it right?
Yeah.
What am I gonna do next?
Take out the constant.
Yes, 2 integral of sine u du. Okay, now formula. What is the antiderivative of sine u du?
Cosine u plus c.
Is it cosine u plus c or negative cosine u plus c?
Cosine u plus c.
Is it positive cosine or negative cosine?
It's positive cosine.
Positive.
Positive?
No, it's negative.
Yeah, I was gonna say it's negative.
It is negative, right? Can you please go back to your notes?
I just did. It's negative.
Using
Oh, never
myself.
mind. It's negative. Yeah, it's negative.
It's negative, right? That's why I said Rebecca almost got it, because her answer is correct, but the sign is not correct. So that is important in calculus. Make sure that you know which one is negative and which one is positive, because in derivative and antiderivative, it switches. So this one should be 2 times negative cosine u plus c, right? So I'll have negative 2 cosine 5x squared minus 3 plus. And that is the answer I'm looking for. Is there anyone here who got the same answer as me?
I did at the same time.
Good. Let's have another one. Ready? This is going to be the last problem for the day. And let's make it more fun. I'll throw in the integral of 6e raised to 3x cosine e to the 3x minus 5 dx. Okay. What do you think is my u in this problem?
E to the
3x minus 5.
Okay. Do your magic.
Sine times e to the 3x minus 5.
6 sine. e to the 3x minus 5 plus c. Okay, that's Rebecca's. Is there anyone here who has a different answer?
Yeah, I got 2 signs.
Michael got 2 sine u plus c instead of 6 sine. Any other answer?
That's what I got, the 2 sign.
Marvin also got the same answer as Michael. Let's see, is it Rebecca or the 2 guys? I don't know.
It's the guys.
What is the du in this problem?
3e3x,
Yes,
ex.
3x. Don't forget the dx, okay? Now let's change this into an integral of copy, change, copy. So this is the only thing we change. Now, what do you notice? We have the dx, we have the e to the 3x, but we don't have the 6.
That's
So,
multiply 2 by both sides.
yes, we're gonna do a little bit of algebra. Multiply this by 2, multiply this by 2. So now we have 2 du is equal to 6e to the 3x dx, which is now identical to the function. So now our function will turn into the integral of cosine u. This whole thing will turn into what?
2 du.
2 du. And now constant out. And we're looking for the integral or antiderivative of cosine u du. And what is the antiderivative of cosine u du?
Sine u plus
Sine
c.
u plus c,
Sine u plus c. Is it negative or positive?
positive.
Oh, not yet. 2 sine e to the 3x minus 5 plus. All right, to be more politically correct. All right, and that's it. That's the only challenge is, to be honest, it's the first problem because there's so many layers on this problem. And you really need to know your algebra to be able to do this. So we've done a lot of transformation in this problem. That's why it can be a little bit challenging. But the rest of the problems are pretty straightforward. Like this. All right. Oh, it's right here. I've been looking for this. Open the chat box and open the participants so I would see all of you. There you go. Let me fix my desktop. Are you still there?
Yes.
Yes.
Can you hear the noise in the background?
No.
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 Perfect. I guess I set up my mic correctly this time because there's construction going on in my house. I had a water leak of all the time in the year. So my house is a mess. And I'm not happy. All right. Where's that? All right. Okay. So U-substitution, that's what we're going to be working on. So let's say, get your pen and paper ready. And we're going to solve for the integral of x square root of 2x minus 1 dx. So how do you find the antiderivative or the integral of this particular function? So this function would require us to use a different technique because obviously the function is a little bit more complex than the usual functions that we play with last week. And to work on this, we're going to modify this function so that we can use our basic integral rule to solve this problem. And to modify this function, we're going to set a variable u. That's why it's called U-Substitution. So in this case, most likely, we'll have problems like this, and we're going to have U-Substitution and change that into u. All right, so let's do that. So let's say u is equal to 2x minus 1. Since that is a more complex function between x and 2x minus 1, right? So what is the derivative of 2x minus 1?
2.
Call it du. It is 2
Yes.
dx. And every time you take the derivative of a certain function, you just need to write the dx to, it is a command to tell us that we already took the derivative of that function. That's why it's 2 dx. Okay, now that we have u as 2x minus 1 and du as 2 dx, we're going to modify this. And how do we modify this? In terms of u. So the new function will turn into antiderivative of x times the square root of u times dx, right? So we know that 2x minus 1 is equal to u, so we change it into u dx. Now, further modifying this, we'll have x times u to the 1/2 times dx, right? Right?
Yes.
Okay, now the next problem is we have an annoying x and dx in the function. So what we can do is to further modify this so that it would work for us. So what we can do is to change the dx into this function. And how are we going to change it into that function? We're going to change it into multiply this by 1/2, multiply this by 1/2, and we'll have 1 du equals dx. Now, we can change the dx into 1/2 du. So we'll have the integral of x times u to the 1/2 times du is now going to change into 1/2 du. But we still have an annoying x. How are we going to change our x in this function so that all of them will turn into a u function? Because remember, when we're trying to integrate or differentiate, we need to have a single variable. So do you have an idea how we can change that x into a function of u?
No.
Do you solve the u and make it equal to x?
Yes. Let's modify the function u is equal to x minus 1 and change it into an x. So let's do that. So now we'll have, geez, I chose a problem. It's too complex to begin with. I could have chosen an easier one. Anyhow, if we're already here, might as well answer this. So u2x minus 1 can be changed in terms of u using algebra. So u equals 2x 1. Change it into an x. We'll have u plus 1 equals 2x, right? Right?
Yes.
And then we have u plus 1 equals x times 1/2. Right?
Yeah.
Yes.
Okay. And now we're going to modify this x into the antiderivative of 1 u plus 1, right? Because now it's in terms of x times u to the 1/2 times 1/2 times du. All right, now let's do a little bit of algebra. And that algebra is taking this constant right here and put it away. So let's put it away and let's have 1/4 integral of u plus 1 times u to the 1/2 times du. So now all we need to do is take the antiderivative of this function. Now, what do you think is the next algebra technique that I'm going to use to take the antiderivative of this function?
Distribute.
Yes, I can distribute u to the 1/2 to u and 1, which means I'm going to add their exponents, right? So if I multiply this and this will be the integral of u to the 1/2 plus 1, right?
Yes.
Okay, law of exponents, you add exponents when you're multiplying this, and this one will turn into positive u to the 1/2, right? du. And of course, don't forget your 1/4. Constant rule. Ignore the constants and just deal with the functions later on. And now we have the integral of u to the, what is 1/2 plus 1?
3/2.
3/2 plus u to the 1/2 times du. Okay, now, don't forget the constant. We're going to be integrating each function with respect to u this time. So you will integrate this. So can you please give me the integral of u to the 3/2 and the integral of u to the 1/2? Of course, this is with respect to u, so du. Okay, integrate. Are you done? What is the integral of u to the 3/2?
I got 2/5 u to the 5/2.
I got the same thing.
Me too.
Okay, so can I just copy it? What did you get? 2/5?
Yes. U to the 5/2.
And that is correct. What about the other one? U to the 1/2.
2/3 u to the 3/2.
Is there anyone here who has a different answer?
And du part.
The du part, once you take the antiderivative of that function, the du will disappear. It's just a plus c. But then we're going to multiply it.
Right.
1/4, right? Because we still have the 1/4. So multiplying it by 1/4 will have, this one is easier. Just distribute it. 2/20.
1/10. Or do you want to simplify it yet? Or
2/20 or 1/10.
1/10. U to the 5/2 plus
6.
plus 1/4 c, or a constant c times 1/4. All right, now we started with x function, so we need to return it back to an x function. So the final step is to replace all the u's with x. And what is the value of our u?
2x minus 1.
Yes. So the final answer is 1/10, 2x minus 1 to the 5/2 plus 1/6, 2x minus 1, 3/2 plus 1/4 c. Or just c, or a constant c, because it's just any constant. All right. Is it hard? It is hard. I didn't expect it's going to be this hard. All right, I should have chose an easier or simpler problem. So I hope you got the idea of how to integrate with substitution. And I'm going to choose an easier function so that you don't get too traumatized with all of these beautiful work right here.
Thank you.
Okay, do this on your own. Forward and pretty simple. So your homework for tonight or for this week, it's going to be all about U-Substitution. And again, practice, practice, practice. Because the next problem or the next work that we're going to be working on will be a definite integration, which means the integral sign will have a lower limit and an upper limit. And that's what we're going to be working on next week. So do you have any question? Were you able to learn something today?
Yes.
Good.
Oh, for sure.
So for you not to lose it, practice and answer the practice exercises that I'm going to be posting in our Canvas page. Answer them. Make sure you work on that immediately, because if you wait, you'll forget. Because I know you guys, you can easily forget things. All right, and that's it. No more questions.
So what are we doing for our final and other quizzes and stuff?
When am I going to assign quizzes and stuff? I don't know. I'm not there yet still. We still have 4 weeks. So we still have 4 meetings. I'm probably just gonna give you 1 quiz or 1 test for this semester because I want to. All right, so just 1 quiz. So this is an easy class. Well, not really. This is an easy class if you're coming in all the time because our attendance is graded. Now your homework and your quizzes, you can make it up if you missed it. You're not gonna get 10 points, but it's better than 0 points. And make sure to just be responsible with all your submissions, because if you're on time all the time, you'll earn your A in this class easily. Okay? So yeah, I don't have any problem.
You said you're gonna post the homework, right?
Of course I will. I will post it. It's not posted yet because I need to make sure that you know the skills needed for the items that I'm going to choose. And now that I'm confident that I taught you the skills, you just need to show it to me through the homework. And I will post it. I'll post them right away so you won't forget. All right, so thank you so much for coming. I appreciate your attendance. I'll see you all next week. And next week, different skill, new skill. And since you don't have any question, and this is recorded, and I'm gonna end this now. Bye.